So now that you generalized a strategy, we're going to look more at the notation that is involved. So when you said 47 plus 21 is the same as 68, and then you said, well, I know that negative 47 plus negative 21 then has to be a negative 68. And you might have said something like, well, I'm just going to add them as if they were positive, and put a negative sign out front. That's what most young kids or middle school kids would say. So how do I write this notation? So again, if I'm adding the same size numbers, well, if they're both positive, then A plus B, A and B are positive, is the same as, well, just the absolute value of A plus B. Adding two positive numbers is going to give me positive numbers. So now let's look at the notation as if they were both negative. Well, then A plus B would be equal. Well, you just said add them as if they were positive numbers and put a negative sign out front. So if I was going to add them as if they were positive numbers, this would be the absolute value of the first number plus the absolute value of the second number. And then I'm going to tag on that negative. And we could check it, right? This would be the absolute value of negative 47. Oops. Plus the absolute value of a negative 21, and then I'm going to put a negative sign out front. Well, this would be the same as a positive 47 plus a positive 21, and put that negative sign out front. And now I know this is actually indeed what my rule said. So how about if they were different in sign? So you might have made some generalized rules again in words for adding different sign numbers. Now our goal is to put them into algebraic notation. So we're just going to suppose that the first number A is going to be positive and that the second add-in B is going to be negative. And then we have rules depending on which number is bigger in terms of its absolute value. So if I looked at 47 plus 21, 47 plus a negative 21, you might have seen this as, well, this is the same as 47 minus 21, which is going to give me 26. And I know my answer is going to be positive because if I think about it, I have 47 positives and I'm going to add in 21 negatives. 21 is going to cancel. I'm going to take away 21 positives, and that's going to leave me with 26 positives. So if I think about it in notation, well, this tells me the first number, its absolute value is larger than the absolute value of the second number. That means the absolute value of 47 is indeed bigger than the absolute value of negative 21. So when I add this way, well, I could just think about this as take the larger number in absolute value, A, and I'm going to take away the absolute value of B. That means I'm just going to subtract them as if there were positive numbers, and since 47 was bigger positive than negative 21, I know my answer is positive. Well, let's look at the opposite. 21 plus a negative 47. Well, you might have seen this in your head as, well, I'm just going to take the larger minus the smaller, and this would give me 26. But I know my answer has to be negative because I have 47 negatives and adding in 21 negatives. So my answer has to be a negative 26. So again, you subtracted them if they were positive and then decided what the sign is. So in this case, the absolute value of the first add-in is smaller than the absolute value of the second add-in. The absolute value of 21 is smaller than the absolute value of 47. So you actually started with the larger number in absolute value, subtracted the smaller value in absolute value, and then knew your answer was going to be negative. So again, you subtracted as whole numbers or as positive numbers, and then determined the sign. So both of these kind of generalized rules that we have in words are going to translate to these powerful laws or properties that students can apply.